Identify the chemical species present at the equivalence point. At the equivalence point of a titration between a weak acid and a strong base, NaOH, the acid is stoichiometrically neutralized and completely converted into its conjugate base. Therefore, solution 1 contains the acetate ion, CH3CO2 to the power negative, and solution 2 contains the trifluoroacetate ion, CF3CO2 to the power negative. Compare the strengths of the two starting acids. Look at the given acid dissociation constants, Ka, in the table. Acetic acid, CH3CO2H. Ka equals 1.75 times 10 to the power minus 5 trifluoroacetic acid, CF3CO2, HK, equals 1.0 times 10 to the power 0. Comparing these values, trifluoroacetic acid is a much stronger acid, larger Ka, than acetic acid, smaller Ka. Relate acid strength to conjugate base strength. The strength of an acid and its conjugate base are inversely related by the autoionization constant of water, Kw equals Ka times Kb. This fundamental concept means that the weaker the acid, the stronger its conjugate base. Since acetic acid, CH3CO2H, is the weaker acid of the two, its conjugate base, CH3CO2 to the power negative, is the stronger conjugate base. Determine the effect of conjugate base strength on pH. Because the conjugate base in solution 1, CH3CO2 to the power negative, is a stronger base than the conjugate base in solution 2, CF3CO2 to the power negative, it will undergo base hydrolysis with water to a greater extent. CH3CO2 to the power negative plus H2O is in equilibrium with CH3CO2H plus OH to the power negative. This higher extent of hydrolysis yields a greater concentration of hydroxide ions, OH to the power negative, at the equivalence point, which leads to a lower PO and consequently a higher pH in solution 1. Select the correct option. This reasoning directly proves that solution 1 has a higher pH at the equivalence point because CH3CO2H has the stronger conjugate base, matching option B. The correct answer is option B. Solution 1 has a higher pH at the equivalence point because CH3CO2H has the stronger conjugate base.